Okay. So slant because they're literally slanted. Yeah. Literally, they're slanted. Wait. No. We've done. You guys, Precalc is like algebra 2 review, so you're bored every day. That's why you're talking, right? Anyway, coming back. Didn't you only see vertical and horizontal asymptotes last year, or did you see slanty ones? How do you even do slanty asymptotes? Like, I don't get it. It's either like getting closer, 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 or getting closer, closer, closer. So how would I? Okay, fine. Getting closer, 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 closer. It's the same idea. It's still an asymptote. It's just different because, hold on, review from section 2.6. You just did homework on it. We're grading it today. How do you find vertical asymptotes? Oh, that's rough. Ouch. Vertical asymptotes. Where do they come from? You have a fraction. I'll give you a hint. You have a fraction. Careful. Aiden just gave me a great answer for... Aiden, say what you said one more time. Leading coefficients, he was looking at the top and the bottom. That's not vertical. Those ones are. Okay, so we can find HAs by doing degree tests. Okay, so hold on. VAs, I just heard from domain, and that's kind of true. Kind of true, kind of not, kind of true. So Swain, help me out. Where do vertical asymptotes come from?
The bottom.
Denominator. Good. So what about the bottom thing? What about the denominator?
The ones you can't remove.
The ones? What ones?
X's.
Which X's? There's infinitely many. The X's that make the bottom. Does that make sense? So he knew it. He was like, okay, the bottom, I do something, I get X's, and it's the ones that aren't holes, the ones that aren't removable. But it's the zeros of the denominator that are non-removable. Hold on, someone else. Nathan will count that as yours because you said zeros.
Yeah.
Someone else. What does he mean by non-removable? Can't be factored and reduced away. Can't be factored and reduced away because the ones who are factored and reduced away aren't vertical asymptotes. They're discontinuities, but not vertical asymptotes. Those ones are. The removable ones are. What's the other type of discontinuity besides vertical asymptotes? Turn the boat on. Thank you. Wait, aren't you guys in your notes? This is silly. This is kind of ridiculous. Turn back that page, I bet. There's that heading that says discontinuities. There are 2 points underneath. One is vertical asymptote, the other one is...
Oh.
Oh, thank you. Oh, that's under that. Discontinuities. There were 2. Holes and vertical asymptotes. Anyway, that was fun. Okay, so, long story short, you guys said there was a slant asymptote number 55. You knew it because it was odd. I'm telling you there's one in number 60 as well. What was in common in your homework for number 55 and number 60? Well, slant asymptotes only occur when? The degree of the numerator is 1 more. Wait, this one just says higher than. Careful. It's not just higher than. Higher than, I need you to add in one more thing. By 1. Its degree on top is 1 more than the degree on bottom. If it's higher than by 2 or 3 or 4 or 5, forget it. If it's a cubic over a linear, if it was x cubed over x, it does not have a slant asymptote. Only by 1, and you'll see why right here. If it's a slant, it's a line. If it's a line, the asymptote, it's a y equals mx plus b. What does this say that we're supposed to do to find slant asymptotes, guys? Long division. So guess what we're going to do to this guy? You should be beating me if you're good at this. Or you should have already done it. Not fooling around. Come on, work that brain. That was easy. You guys beat me, right?
Yeah.
huge difference for me preparing you for calculus. Asymptotes, horizontal asymptotes. As x approaches infinity, or as x approaches negative infinity. As x approaches infinity. Horizontal asymptotes, talking about this top guy. Getting ready to talk about slanty asymptotes. Horizontal asymptotes. As x approaches infinity, and or, now that's its own little trickiness because there are much harder functions than you guys are seeing. As x approaches infinity and or as x approaches negative infinity, what is my f of x approaching if there's a horizontal asymptote? A number. If there's a horizontal asymptote at a value, at a y value L, then as x goes to infinity or negative infinity, my function is approaching one number and one number only. Wait, what does this mean again? If x is approaching infinity, what direction am I headed on the graph? To the right? To the right, right? As x approaches negative infinity, to the... So aren't we talking about the end behaviors? Right? To the right, to the left, that was end behavior. Oh, hey, beginning of chapter 2. The evens go up or go down. The odds go opposite, depending on the leading coefficient sign, right? For rational functions, if the function toward the ends is leveling out, there's a horizontal asymptote. Maybe it only levels out one way. Maybe it levels out both ways. Maybe it levels out the other way. Maybe it doesn't level out at all. Forget it. Oh, wait. Forget it. Hold on. This one doesn't level out. Why does this one not level out? Why is there no horizontal asymptote? The top wins. The top degree is higher. Good. I agree. The numerator is higher as far as the degree. Top wins. No HA. Yeah, you're right. It's not leveling off to a horizontal line. But check it. If this is the exact same thing as a line, just a little bit, and if, now I'm going to stretch your brains and try to teach you chapter 12. Not really, but a little piece of it. You ready? If x is going to infinity, x is moving. If I'm going to the right, if I'm going to the left, if I'm trying to figure out end behavior, x is moving, x is changing. X going to infinity means x is increasing without bounds. X going to negative infinity, x is decreasing without bounds. So, if I were to take a quick spotlight right here. I used to know how to find the spotlight, but it's like a new smart program. Oh well, spotlight, we'll pretend. If I was taking a spotlight here. Guys, if x was getting bigger and bigger and bigger and bigger, going to infinity. What's this little extra above y equal x? What's it doing? Getting smaller, getting bigger, becoming more significant, becoming insignificant. Why is it getting smaller? It's a denominator, so 1 over, x is getting bigger. Give me some random starting place for x. Okay. 4. Get bigger from 4. 8. Get bigger than 8. You're going to infinity. Get bigger. 107. Get bigger. You're going to infinity. 1,000. 1,000. 5,000. A billion. As you plug in bigger and bigger numbers. 1 over 5 minus 1. 1 over 32 minus 1. 1 over 107 minus 1. 1 over 5,000 minus 1. 1 over a billion minus 1. What is this doing? Getting closer and closer and closer to 0. Oh, duh! For this part, the bottom wins. That's what we're doing when we talk about degree test. We're actually figuring out what's happening to this guy as x is increasing or as x is decreasing, going to negative infinity. Because even if I'm plugging in negative 5,000 or negative a billion, it's still getting closer and closer to 0. What does that mean? How close is this to the line y equals x? Well, if I'm going to infinity or negative infinity, stinking close. Wait, mathematically, what do we call features of a graph where the function is getting closer and closer and closer and closer and closer to it? It's approaching, it's getting closer and closer and closer to a line. If it's getting closer and closer and closer to a line, it's an asymptote. So just logically, without even the book telling me what a slant asymptote is, anytime I'm going to be dividing a numerator by denominator, simplifying a rational function, and I get a line plus or minus a little bit, That function will always be, well, maybe in the middle it's going to be doing lots of funny things, but at least towards the ends, towards the right and towards the right, or towards the left. As x goes to positive infinity or negative infinity, this thing is getting closer and closer and closer to the line y equals x. So how does the graph look? Was 55 and 60 both graphing ones? Just curious. Okay. If they were graphing, did you guys figure out, well, what they were asking for? I know number 60 at least was graphing. Did you guys see them saying stuff like factors? Oh, some of you don't need this page. But some of you, when you got to those problems where you were like A, B, C, D, E, F, what are they asking you to do? Why were they asking you to factor?
Yeah, we didn't have to do 55.
Oh, 55. Awkward. Okay. Number 60, I just asked so. Fine. What were the directions for number 60? Yeah, there we go. Okay, so it's a whole long list of stuff, right? Okay, so trying to simplify, you figure out the domain first. You should always do that when starting to consider a function. You're factoring because you're trying to reduce out the holes. You're trying to remove any of the removable discontinuities. Y-intercepts, because they just said intercepts, didn't they, guys, in homework? So what were you supposed to be remembering from, well, way back when this year, like chapter 1? Or last year? Intercepts, what two types are there? For y-intercept, don't we just set x equal to 0 and solve? For x-intercept, don't we just set y equal to 0 and solve? Chapter 1. Sketching vertical asymptotes, don't we just take whoever's left, the zeros of my denominator? Like Sway said, that are still present. Find and sketch horizontal asymptotes. Okay, well, wait a minute. Whoa, more than one? Yikes. Anyway, find and sketch horizontal asymptotes. We do our degree test. This is just a quick little summary of all the important information that leads up to the big mama problem of one like number 60. Shout out to Mrs. Leon. Anyway, number 6. Fine, plot, test points. At least one. I'm just saying read a few extra to make sure you're right. And then just smooth curve, connect, and complete. Okay, if you want a picture of this page, it's leaving in about 20 seconds. It was just a quick summary of what ABCD was asking you to do, because all of it was review and or using your homework, but it's sometimes nice to have some little hints or clues, right? But what if we were supposed to graph this guy who had a slanty asymptote? First of all, the first thing that we should have done, there he is, should have been to figure out his domain. So if I'm trying to graph this guy, guys, what would his domain be? Sorry, all real numbers except for one. Good. AKA, x can't be 1. Got him. Why am I trying to, and basically stopping because it's not going to work? Should I have tried to factor? Yes. Does it factor nicely? No. Therefore, okay, fine, I'm stuck. Well, that's a bummer. Although, you could still write it in its different form by doing long division, and you would get what we just showed. So there is another form of it. It's not a nice form where we actually can totally remove the x minus 1, but we can still write it. What's next? Intercepts. We would have figured out our x-intercept and our y-intercept. X-intercept was when y is equal to 0. The bummer is, didn't we just say this top doesn't factor? So what if we set this whole thing equal to 0? Did you guys get stuck at all about how to find the zeros when you had a fraction last night? Because you had to find, for x-intercepts, you had to set the whole thing equal to 0. X squared minus x minus 1. Got it. Don't I need to multiply this to the other side? Okay, so 0 is equal to, some of you might have gotten stuck on that in homework last night. What if you tried to factor and he didn't factor? How do I find his zeros? X equals negative b plus or minus square root b squared minus 4ac all over 2. Oh, forget it. None. Why am I saying none? Emma, you asked this question. Or no. Who was it? Somebody asked, do we put none? Or do we write out the imaginary numbers? Oh, it might have been. Why should we put none? What are we supposed to be doing in these problems?
Real one.
Graphing, yeah. And if it's imaginary, we're not graphing the imaginary one. So we'll just say none. The y-intercept was a lot easier because that one we just have to plug in f of 0, which would be 0 minus 0 plus 1 over 0 minus 1, aka negative 1. So the y-intercept is going to be the point, x is 0, y is negative 1. We go looking for horizontal asymptotes, and we say none. We go looking for vertical asymptotes, and we say, of course, it didn't go away. Remember, only the ones that go away are holes, the ones that are left are vertical asymptotes. But what's going on at the oblique asymptote stage? Or you could say the slant asymptote stage. So let's go ahead and put together what we have. I know there's this whole, like, make a random table of random points, blah, blah, blah. Let's see what we have so far. What we have so far is at 1, a vertical asymptote. What we have so far is a y-intercept at 0, negative 1. And, okay, first of all, did you guys figure out where this came from? Who is this? It's everything, ignoring the remainder, because what happens to the remainder as I go to infinity or negative infinity? It becomes less and less and less significant. It's basically going to nothingness. So as it's going to nothingness, we're just asking who's going to be left at the end? Who's going to be left at the other end? He's going to be left because this guy is just getting more and more insignificant. If we're going to infinity, basically, he ends up disappearing. But how do we graph? Oh, it's a line! How do we graph a line, guys? Isn't that just y equals 1x plus 0? Isn't that with an intercept of 0? And then we go up 1 over 1, up 1 over 1, up 1 over 1, down 1, left 1. But why am I making it dotted? Because y equals x is not my graph. But as I go to infinity, it looks a lot like my graph. And as I go to positive infinity, once again, y equals x is not my graph. But as I go to infinity, it looks a lot like my graph. But wait a minute. What do we have this graph, this function, doing as I come in towards my vertical asymptote? Doesn't it need to skim? Now, how can I be sure that I'm right? What should I probably do? Because literally, how many points did I have? I made this entire graph from 1 point. Well, I knew my slanty asymptote, I knew my vertical asymptote. But couldn't I have plugged in something like 2 and made sure where it was? Right? Couldn't I have plugged in something like 1/2 and made sure where it was, or negative 1 and made sure where it was? I could get a few more points by making a table. But zoom, zoom, you see your slanty asymptote? These are not parabolas. Why? Parabolas keep on going, well, forever in 2 directions. These ones are bounded. These ones are stuck. Parabolas don't have slanty asymptotes, but this function does. Okay, with that, let's go ahead and go grade. So you guys, today in class, we went ahead and said, you know what? In homework, there were really great big mama problems that said, you need to do all of this stuff and put it all together and try to find a graph. We're going to see how you did. But one thing you might have gotten stuck on was, who is this slant asymptote guy? It has to do with x increasing and decreasing without bounds and n behaviors if there is no horizontal asymptote. But the top wins by 1. A long division will always get me a line that my graph will eventually get closer and closer and closer and closer and closer and closer to. So, here we go. Sorry. Here we go. Section 2.6. Oh, weird. Sorry, Honors totally used your grading. Oh, well, you guys can kind of benefit from some of the stuff we wrote down. Section 2.6, number 2, vertical asymptotes. Number 8. Okay, you could have written it in a super nasty way. Or you could have written it in a super nice way. Diego, you good? You could have written it in a super nasty way with words and with tables and with charts, or you could have written it in a super nice way and actually never had to go to your calculator because we learned how to do this with math. Plugging in, checking the sign. Number 12, let me give you a second. Number 12, let me give you a second. All real numbers except for -3/2. Vertical asymptote is at that denominator because he cannot reduce away. Horizontal asymptote, ooh, why? Degree test, come on, it's on the board. Degree test, why is it -7/2? They're tied, and he's a negative, he's a positive. But if you want to be super snazzy and have a calculus mind, didn't we say horizontal asymptotes are what's going on at the ends as x approaches infinity or negative infinity? And as this grows and grows and grows and grows, he becomes insignificant. And as this grows and grows and grows and grows, he becomes insignificant. So kind of like what we just looked at, how it was the line with a little extra that became or ended up not really mattering at the end, at the infinities. At the infinities, what's going to remain is the -7/2, and the 3's aren't going to make a difference. But maybe none of you tracked with that, and that is okay. We have not learned the idea of a limit yet. P.S. You should look at chapter 12 and see what the title is. Or remember that our book is Precalculus with limits. Number 22. You got stuff. Wait a minute, what's this magical chart that they just randomly plugged in numbers? That's exactly what they did. They randomly plugged in numbers. Why? Because they wanted a little bit of extra proof as to why it was what it was. Because they were trying to get this graph. Now, you might not have chosen their random numbers. That's totally okay. I wouldn't have chosen their random numbers. Because if I had done the work... Can I zoom out just a little bit? Sorry. There we go. If I was doing a chart of random numbers to try to make sure I was good, I would think of what I had, and I had 0, 1. I had 1/3 0. To be honest, I would have thought, you know what, that's enough. Swoop, there he is. Swoop, there he is. And then I would have done a couple over here, like around 2 and 3 to swoop, there he is. And I would have been done. Why? Because horizontal asymptote, I have to get closer to. Vertical asymptote, I have to get closer to. Done. All I need is a few to show me the curvature. Anyway, that's what they're doing with the charts. It's not some huge strategy that you have to perfect. It's just a few extra points to have an idea. 42 is A, 43 is C, 44 is B. I don't remember why I put that. There might have been a typo. Something was weird because I typed it in. Beware count chat on 43. Might have been 2. One more? Haha. Slanty asymptote, you see him? You see where he came from? Do you see why they wrote it like this? What did they do from here to here? Long division, good thing. Long division, right? It's a line! A little bit that becomes more and more insignificant as you go to the ends. To the ends, it's going to look like a line. There's just this weird funky stuff in the middle that I have to realize with my vertical asymptote. I got my intercept. The x-intercept is none, another imaginary number. Unfactorable. No nice factors, no nice rational factors. Actually, no real factors. Quadratic formula, they would have been imaginary when you looked for the zeros or for the x-intercepts. Oh, are you kidding? We had to do... No. What's the table for?
Random numbers.
Yeah. Did you have to pick the random numbers they picked? It got silly, gross, disgusting fractions? Yeah. Could have picked something a little bit easier. Maybe like 0. Oh, wait, we already did that one. Like 1. Okay, cool. 3. To be honest, maybe that was enough to swoop it and swoop it and something. Real quick, I want you guys to hold up your homework showing me number 60. Real quick, show me your number 60. Show me. Find me number 60. Find me number 60. Number 60. Just point to it. Put your finger on it. You guys know what I'm seeing right now? No, I'm not seeing a lot of cheating. It's an even, so it was kind of hard to find unless you went on Slater. You know what I'm finding? Minimum on most. Lucas wasn't the only one. There were a few. Some of you actually graded it and were like, I got stuck, but this is what's supposed to be. And some of you, it's still blank. Confusing. Number 80, true, true, and false. True, true, and false. Guys, if you want me to trust that you totally know what's going on in this class, and I can kind of give you some freedom in class to goof around a little bit, you got to show me that you know what you're doing, and that did not just show me that you knew what you were doing. Oh, but there was a slant asymptote. How much of that problem was the slant asymptote? Confusing. All right. Hopefully, some of you guys have homework questions for me, but number 60 I'm not going to take because we just spent a long time making number 60 understandable. Anything besides number 60 we were stuck on? Oh, true, true, false. Do you guys want to see it? It was there for like 2 seconds. Oh, now I just had way too. Oh. I don't know. We'll go over to the mouse. Told you it's possessed. All right, number 80 was true, true, false because letter A had to do with the vertical asymptote. Letter B was true, having to do with the horizontal asymptote because the degrees were tied, and letter C was false because the ratio of the coefficient should have been 2, not 1. 80, I heard you say yes, 80. Were you confused on that one?
No,
or just 8? Yeah. Anything else besides 8? Going once, going twice? No odds, no evens? Emma's looking. Let me go look at number 8 and see what's going on. Number 8 was 80. And then 80?
Yeah.
Okay. 8 and 80. Let me know if you have something else. 8 just says, what are the discontinuities and discuss the behavior? Why am I going to say real quick that the discontinuities are both vertical asymptotes at x equals plus or minus 2?
Because the bottom one is x squared, which means there's 2.
If I was to factor the x plus 2, x minus 2, or if I was to solve equal to 0, plus or minus square root of 4 would be plus or minus 2. But when it says discuss behavior, Aiden, it actually asks you to go one step further. Now, in the book, it was like, oh, plug into your calculator, go to your table, do tons and tons of work. I would have said, rewrite it in factored form, but then use your really cool notation to save you time. And your really cool notation says, okay, what's going on as x goes towards negative 2 a little bit below, and as x goes to negative 2 a little bit above. We're trying to figure out where my y's going, up or down. That's the long story short. They're just trying to have you be able to figure out pretty quickly if I have a vertical asymptote, which I have a vertical asymptote because I couldn't cancel them out. Okay? If I have vertical asymptotes, we were just graphing rational functions a second ago. Wouldn't it be nice to, okay, maybe points kind of point us in the direction of where it's headed, so maybe we can cheat just a little bit. But once again, remember that I'm preparing you for calc. So couldn't we figure out where the y's are headed as we come in? That's what they're saying. What's going on as you come in towards it? Is it going up or is it going down? Well, that's the nice thing. You know it's either going up or it's going down. We need to figure out which infinity. Both positive, both negative, one of each. And how we do that is, oh, someone help me out. How do you not have to use a calculator for this? What's something a little... You see it? On a number line, negative 2 is here, negative 3 is below it. I need negative 2.1. This would be like a negative 2.1. So imagine plugging in a negative 2.1. And you just need to check the signs. So on top, I have a negative. On bottom, I have a negative times a negative. Wait, a negative over a negative negative. Isn't a negative negative a positive? And a negative positive is a... So Aiden is kind of taking one test point instead of a whole table, plugging it in, and just saying positive or negative, up or down. And by plugging in, I figured out, without even caring about the value, I figured out going down. And so what you would do is you would keep doing that. So in the answer key, I rewrote that big old nasty table with the words. Please don't freak out. Oh, okay. No. It's not even stopping when I tap the screen. It's kind of a lost cause. So Aiden, check it. Like that was their answer. 3 paragraphs, 4 tables. Mine's just a little baby off to the side of, hey, I saw what was going on from the left of this guy and from the right of that guy. I just use snazzy notation by plugging in a test point. And I'm going to plug in 1.9 and 2.1 to figure out what's going on the other way. Okay, Emma, 80, right? Yeah. Okay. Anything else besides 8 and 80? Going once, going twice? Sold. Killing me, Nathan.
Sorry.
Okay, number 80. How do you see it? They didn't give you much. Here's the struggle. They said, hey, it's a rational function. Who knows the numerator? Who knows the denominator? But here's the graph. From the graph, can't we tell that my denominator has a 0 at x equals 1, so therefore I have to have somehow an x minus 1 down there? What else do I know? I have HA at y equals 2, which means somehow the only way to get a 2 is if the ratio of the leading coefficients was 2 over 1. So that must have come from 2 over 1, and there must have been a tie. So somehow these guys are tied. Okay, let's figure out. D of 1 equals 0. Denominator of 1 equals 0. Oh yeah, of course. There's a vertical asymptote there. Vertical asymptote means that had to have been a 0 of the denominator. Check, that has to be true. All vertical asymptotes come from zeros of the denominator. Letter B. Degrees are tied. Yeah, of course, there's a horizontal asymptote. There had to be a tie. It wasn't 0, it was a number, which is only possible from a tie. Check. And then letter C, the ratio of the leading coefficients is 1. No. Horizontal asymptote is at the ratio of the leading coefficients, and the horizontal asymptote is at 2. 19, Nathan? What were the directions?
State the domain, identify all intercepts, find any vertical or horizontal asymptotes.
I believe this is what we would call a big mama problem, right?
Yeah, but the most
what was the hard part?
With was D, like the plot additional solution point.
Got it. Remember, there is no magical table, it's just get a few extra. So as I'm looking at this guy, basically trying to get a sketch. You see it? All of this builds you up to sketching.
Yeah. Okay?
So as I'm trying to get a sketch of this guy, and you already identified all the other ones, they say plot additional solution points. What the? Oh, get a few more points. That's it. Get a few more points. Because in your graph so far, when you've done all the rest of it, you should have gotten your x-intercept to be -1/4.
Yeah.
Oh, when x is 0. Sorry, the y-intercept to be -1/4. Got it. Vertical asymptote?
-4 and y equals 0.
And then you have a horizontal asymptote of y equals 0. What does this look like? Really? I mean, we could guess and say, well, I think he's getting closer and closer and closer to the asymptote, and I think he's getting closer and closer and closer to the asymptote. We could make sure we're right by doing that whole little, hey, as x is going in towards -4 from below, as x is going in towards -4 from above. We could like plug in -4.1 and -3.9. We can actually put that in our table if you want. That could be letter D. Like that would be one strategy. But to be honest, they didn't even mean for you to really like do decimals and get crazy stuff like that. They were just saying, can you just see where you have a lot of blank space and you don't know what's going on? Plug in a few points.
Okay, so just like random
Exactly.
that are
Well, kind of random, but maybe I would have done like -5, -6. I'm going in order. And then maybe just to make sure, I would have done like a -2. And when I found my point, I'm like, oh, sweet, got it, right? And when I found my couple points, maybe I would have been like, so do you really need tons? No. The book might do like 6. I think 2 or 3 is fine. Okay. Dun, 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 dun. Woo! Section 2.7 that we are, check out the backboard, starting today. Don't hurt yourself. Section 2.7 that we are starting today asks the following question. Section 2.7, as you guys get ready to go. I'm going to write them on the front.
There's 5 minutes.
Following question.
I know, like 7. 35? 37.
Go ahead, you guys can do that. Last section of chapter 2, which is why we have a test next week. It's supposed to be tomorrow, but that didn't work out. As you guys are starting to write down what we're trying to solve, just to give you a sample problem, give you a sample couple problems. What if we have x squared minus 7x minus 18 is, oh, let's not even do that. That's no fun. 16. Solve! I see a non-line and an inequality. Do you guys see a non-line and an inequality? I see a non-line and an inequality. Oh, good thing we have a section on non-linear inequalities. This one has a polynomial with an inequality. That's going to be the first half of 2.7. Not the first half, but the first type of problem. The other type of problem is going to be, well, that's not how the or equal to. Let's make it greater just for the heck of it. Ooh. I see a nonlinear and an inequality. You guys remember what the first half of chapter 2 was all about? Actually, more than half, 2:1 to 2:5. With a little like aside on imaginary numbers, it was all about polynomials. And what was section 2.6 all about? So what does section 2.7 say? Well, how do we deal with these dues when they aren't functions with equals, when they're instead inside other problems with inequalities? Now you guys are taking notes, totally cool. I'm just going to go ahead and reword this a little bit. What is the quadratic above or hitting y equals 2? Or over here, when is the rational function above y equals? Not above, that doesn't make sense. Isn't that a less than? Below. Those inequalities, they're actually statements. They're statements that have meanings, and the meanings are above or below. They're statements that have meanings. The meanings are above or below. But mathematically, how the heck are we supposed to solve? What's something that your brain is saying right away for the polynomial one? Come on. Factor! Ah, but 16 making 7 doesn't make sense. It shouldn't make sense, because what's over here? I never factor quadratics when it's equal to a non-zero. What do I always do first? Get the 0. Hey, what do you see on this page? Polynomial inequalities. All polynomials have these key numbers, which are their
Zeros.
key numbers, which are the zeros. So the very first thing in solving these problems, I'm not going to get through the entire thing today, of course, but the very first thing I need you to see is polynomials have these things called key numbers that are going to be super important for being able to solve that. And rationals, the next page, has their own key numbers. And in some ways they're the same. Both of them say solutions. Both of them say solutions. But for polynomials, we can always get a zero. So my hint for this one is to get one side equal to 0. Maybe it already will be. And factor. Which is great, because we've basically spent, 2, 2, 3, trying to review factoring. So we're going to get one side equal to 0 and then factor. Now we're not going to be done, but we are going to have our key numbers. They're called our separators for our answers. For rational functions, we're going to have solutions also, but we're also going to have undefined points. So there's an extra one. For polynomials, just the solutions. For rationals, we define solutions and undefined points. And the reason we're doing that is because these key numbers will split our domains into intervals. And some of those intervals are going to be true and thus a part of my solution, and some of them are going to be false and thus not a part of my solution. And the nice thing is, because of this fact, that a polynomial can only change at its key numbers and a rational can only change at its key numbers, kind of like how Nathan asked me about how that weird table, like what are we supposed to do? And I said, try one here and try one here and try one here. And it was enough to tell me everything. That's what we're going to do in section 2.7. We're going to start by finding key numbers of polynomials, key numbers of rationals, and then we're going to basically set it up and say, okay, what's the big picture? What are my different intervals that have been formed? And then just try one number there, one number there, one number there, and say true or false. If it's true, that whole interval is part of my answer. If it's false, that whole interval is not a part of my answer. And then we're done with section 2.7. Sounds easy?
No.
It's not as hard as you think, as long as we get our process down tomorrow. So tomorrow, our goal is the half hour that we have in class?
Yeah.
Homecoming week. Tomorrow, the half hour we have a class. We're not going to work on how to factor. You sure already know that. We're not going to work on how to find solutions or signs. We're going to figure out how to test true. Right? What work do you want Monday?
We only have like 30 minutes.